Alright, so I'm going to explain how I arrived at all my answers for class activity 5D, which is explaining why the procedure for multiplication fractions is valid. So for problem 1, it said for each of the rectangles, fill in the blanks so you can use multiplication to describe the fractions of the rectangles that is shaded. You may assume that all lengths that appear to be the same really are the same. Alright, so for this picture here, initially, so I see that I have one little tiny square is shaded out of the whole thing. So I added lines, or continued the lines, and then realized that there are 12 total squares in here. So I have one unit of 12 is shaded. So now to figure out what the fractions that are multiplied were, I see that my smaller breakdown here is this particular this row right here, which is broke down into four blocks with one of them shaded. So that is 1/4, and I put that on the front because I'll explain that in a second. And then the other one, I realized that the whole entire block is broke down into 1, 2, 3 three sections, so thirds, and one. In order for this to be colored here, that means 1/3 is colored on there, or 1/3 of the amount of space is shaded. So that fraction 1/3 goes right here, and essentially 1/4 times 1/3 equals 1/12, or 1/12. And then for B, similar here, I saw that 3 of these size spaces on the cube were shaded, so I extended all the lines, and I determined that there were 20 spaces of this size, and that 3 of them are shaded. So I put 3 of 20 on the top. Now, similar to how I found my fractions, I went to where the individual ones here were shaded, and I looked at just this row and I realized that 1, 2, 3 out of the 5 of them are shaded. So that was my starting fraction, 3/5. And that's shown right here. 1, 2, 3, 4, 5. And then I also demonstrated what the 1/4 box looks like, which is 1/4 of its shade. Or I realized that it was also in fourths, 1, 2, 3, 4, and that this row would have been the only one that could have been shaded. So your other fraction is 1/4. So 3/5 times 1/4 is 3/20. For C, I see that there are these squares shaded. When you extend the lines, that makes 2 of the 12 2 of 12 shaded. And then for my first fraction, I looked at just this row, and that tells me that 2/3 of this row is shaded. And then I also looked at, and I realized that it's also broke down into fourths, and 2/3 is shaded. And then it also broke down into fourths, 1, 2, 3, 4, and 1/4 of it is shaded. So 1/4 times 2/3 is 2/12. And then for D, I did the same thing on the other ones. I counted 9 squares that were shaded, and there's a total of 20 when you extend all the lines. And then I essentially pulled the array apart and split it up into what it is. So you have a fraction of the whole thing is broke down into 3 there, so it's broken into fourths going this way, 1, 2, 3, 4, and obviously since those are filled in there, 3/4 of the rows are filled in. So 3/4 is one of your fractions, and then for this 1, 2, 3 out of 1, 2, 3, 4, 5, so 3/5. 3/4 times 3/5 is 9/20. All right, so for the next one, it says use math drawings to explain why 1/4 times 1/3 equals 1/4 times 3. Discuss how you're interpreting 1/4 times 1/3 and how that fits in with multiplication. So 1/4 times 1/3, the way I look at that is, that is a 1/4 of 1/3. We're looking for 1/4 1/4 units with 1/3 in them, essentially. And then because that would be m times n, is m units units of n-sized units, or whatever you want to say. So, and if you look here, so we have this one square here, and then you have this other one which is broken into thirds. This one represents 1/3 of 1 unit. This one here represents, this shaded part individually here represents 1/4 is shaded of, or 1/4 of this bar is shaded, which is 1/3. So 1/4 of 1/3 is shaded. When you put them on top of each other and you extend all the lines, you see that you have 1/12 is shaded. And so 1/4 times 1/3 is 1/12, which is also equal to 1/4 times 3. Another way you can see that is the numerator generally represents, what I've discovered, numerator represents the shaded portion of your answer, typically, which is 1, and then your denominator represents the total number of equivalent spaces to that shaded one. So you got 1, 2, 3, 4 times 1, 2, 3. 4 times 3 is 12, which 1/4 times 3. Okay, that's that one. Now we're going to move on to this one right here. We're going to use the math drawings to explain why 2/3 times 5/8 is 2 times 5/3 times 8. In particular, explain why we multiply the denominators and why we multiply the numerators. Discuss how you're interpreting this. So I'm interpreting 2/3 times 5/8 as 2/3 of 2/3 whatever this is of 5/8, 2/3 units with 5/8 in them. So it's 2/3 of 5/8. So this first box here represents 5/8 of 1 unit. This box here represents 2/3 of that 5/8 chunk. So we have 2/3 filled in of the 5/8 chunk. So then when you put them on top of each other, you have you end up with essentially 10 of a grand total of 24 spaces, so 10/24. But the reason since I think I said on the other problem that the numerator represents the shaded, represents the shaded portion, or represents the portion of the fraction. So, and that is, if you look here, 1, 2, 3, 4, 5 times 1, 2. 5 times 2 is 10, which fits in with, or 2 times 5. You see it right there, 1, 2 times 5 on the top. And then the bottom, the denominator, tends to represent the total number of equal spaces within the unit, which is going to be 1, 2, 3 times 8. 8 times 3 is 24. So, and that is why 2/3 times 5/8 equals 2 times 5/3 times 8. And then finally, the last one here. Okay. Okay, and then this says use the definition of multiplication and use math drawings to explain why 2/5 times 3/7 equals 2 times 3/5 times 7. This is very similar to one we just did. And I interpret 2/5 times 3/7 to be 2/5 units of units containing 3/7. So 2/5 of 3/7. So the way I did it, got 1 unit here, then I represented 3/7 to show you 1, 2, 3 shaded in, and then I represented one that just had broken into fifths, 2/5 shaded. Then over here you can see I impose them on each other, like put them on top of each other, which gives me so like this one here is 3/7 of 1 unit. This is 2/5 of 1 unit. And then over here, so the shaded portion represents 1, 2 times 1, 2, 3. 2 times 3 is 6, or 2 times 3, which is what I'm trying to show you here. And then the denominator, we multiply the denominator because the denominator represents the total amount of equivalent spaces of the unit, the numerator's unit. So, and that is going to be 5 times 7. And that is why it works to multiply 2 times 3 over 5 times 7. Thanks for listening.